and then a few hours later at high tide, the whole flow reverses, and the river's dropping a few metres in height the other way. And so the obvious question I had was, why has nobody turned that bay into a power station yet? Actually, question number one, why are the tides so high here? To answer that, I'll use the bathtub in my hotel room. For this scientifically rigorous demonstration, the Bay of Fundy is represented by the bathtub, and the Atlantic tides and all the unimaginable pressure created by megatons of water is represented by my arm. So, moon pulls on the ocean, tide comes in, pressure gets applied, and a wave heads down the bathtub, the Bay of Fundy, and bounces back. Because it's not like the water all rises simultaneously. It takes time. And yes, the scale here is colossally different, but you still get a wave effect, a reflection, and a trough that follows the wave. Tick, tock. Tick, tock. And that will always take roughly the same time to go up and bounce back. It'll be affected a little bit by the weather and water temperature. So what happens when the next tide comes in? If I time each push to go with the wave that's already there, then very quickly you start seeing a resonant frequency and a lot of power. That worked way better than I expected it to. The resonant frequency of the Bay of Fundy is roughly 12 and a half hours, the same as the tidal cycle. Combine that with geography that's less like a bathtub and more like a funnel, getting tighter and tighter as that wave comes in, and you have the highest tides in the world, right there. The power is immense and it's obvious, and if it could be harnessed, then it'd be reliable and renewable. Intermittent, sure, but on a schedule that would be simple for the grid to predict and plan around. So why aren't there tidal power stations all around the Bay of Fundy? Well, the answer is it's been tried. A lot, usually in the Minas Basin, where several companies have put millions and millions of dollars behind technical trials. And every time, the Bay of Fundy breaks the turbines. 2009, a turbine was torn apart. 2010, two blades broken off. 2018, damaged beyond repair. Turbines in these waters have to be light enough to spin, but strong enough to resist high-speed salt water that carries huge amounts of sediment and big rocks along with it. And in winter, enormous chunks of sea ice. Oh, and that's before we even start talking about the concerns from First Nations people and commercial fishing operations that maybe putting a load of giant spinning things in the water might cause some problems for fish. But people are still trying. There are more experimental turbines planned. Can it be done? Maybe. I thought about doing long interviews with the tidal power companies and their opponents around here, but those interviews would have sounded the same 20 years ago. And the result would just be a much longer way of saying, maybe. If it can ever be done safely and reliably, it'll be brilliant. I hope that happens. But there's also a decent chance that the Bay of Fundy is just going to tear the turbines apart again, and in 20 years, the answer will still be maybe. And now, today's sponsor. I saved $200 on the rental car that